All right, now we're going to use the British method to help us solve quadratic equations by factoring. So, a couple steps here. First of all, if my equation doesn't equal 0, I have to rearrange some things. I should probably do that. So, first step to solving is set the equation equal to 0. Then I will factor the expression, probably using the British method. Then I will solve the equation using the zero product property. So, here we go. First problem, I need it set it equal to 0, so I'll go ahead and subtract 35 from both sides real quick. Rewriting this, I have 2x squared minus 3x minus 35 equals 0. So if it were just x squared at the beginning, I could factor it using guess and check, but since there's a 2 in front, maybe I'll use the British method. 2 times negative 35 is negative 70x squared. Factors of negative 70 add up to negative 3. Again, this is the hard part of the British method, but I think it's going to be negative 10x and positive 7x. Those add up to negative 3x. They multiply together to be negative 70. That's good. Bring down the outside terms. I got a 2x squared here, and I got a minus 35 over here. The next step in the British method is to group. So GCF of the first pair, 2x, leaves me with x minus 5. GCF of the second pair, how about a 7? Also leaves me with x minus 5. Tremendous. That's what I wanted. Because now I have a common binomial factor of x minus 5, which I can factor out. And that leaves me with the leftover factors, 2x plus 7. They go together. And now I'd be done if the instruction said factor, but the instruction said solve the equation. So I'm going to go ahead and put equals 0 on the right side once again. Now to solve this, when it's in factored form, I can use the zero product property, meaning if I can make this expression equal 0, it won't matter what this is. So remembering what we did in previous lessons, what makes this equal 0? How about 5? Because 5 minus 5 is 0 times, who cares what that is? It's going to equal 0. Now, the other one, not quite as obvious as this one being 5. Eventually, with enough practice, these will become just as obvious as this one is. Until that point in time, here's what I would do. I would take this and just kind of solve it separately. I need 2x plus 7 to somehow equal 0. And again, in time, you'll be able to just do this in your head. Well, to solve for x in this equation, I'd be subtracting 7. And I'd have 2x equals negative 7. And then I would be dividing by 2. An ugly 7. So negative 7 over 2, that's what x would equal. Okay, so x equals negative 7 halves. And eventually, the pattern you will start to recognize, you take the opposite of this number divided by the first number. That's going to be how it works. So there's solving a quadratic equation using the British method. We'll try one more. Again, does my equation equal 0? No. Are there parentheses? Oh my goodness. What a mess. Let's get this equal to 0 first. I don't like parentheses early, so I'll go ahead and distribute, which will give me 3x squared plus 14x. I will also subtract the 5 all in one big giant step. So I'll have a minus 5 here, and I'll have an equals 0 over here. Now, I use the British method to solve this, but I've already done that in a previous video. If you remember, this is the exact same expression that we started with just a couple of videos ago. Right here, 3x squared plus 14x minus 5. X plus 5 and 3x minus 1. Let's see. Let's just copy those. Can we? Maybe not. X plus 5, 3x minus 1. Remember that. X plus 5, 3x minus 1. Those will be our factors. Again, just saving time here. We've already done this one. Just want to show you what the answer is now that it's asking us to solve. All right, the obvious answer. What makes this equal 0? How about negative 5? The other one, not quite as obvious, but a little mental algebra here would tell me I'd add 1 divided by 3, so it must be 1/3. There's my two answers. Neat stuff. Solving quadratic equations with the British method.